you're watching a chef slice into a fresh fish. Red blood gushes out, just like it does from every vertebrate on Earth. That's biology's most basic rule. If it breathes, it bleeds red. But now, slice open an ice fish. Nothing. A clear, almost glassy liquid oozes out. No iron, no red, no hemoglobin. It's not blood, it's something else. And yet this fish is alive. It swims, it hunts, it breathes. This isn't just a weird animal. This is a biological ghost. The only known vertebrate that completely gave up hemoglobin, the very molecule that makes life possible. You can literally see its brain through its skull. Its blood is so clear, it's like vodka running through its veins. No, this isn't a lab experiment. It's very real, and it breaks every rule we thought we knew about how animals survive. So how is this thing not dead? How does it get oxygen? Why would evolution delete the one molecule nearly every other creature depends on? This is the story of the Antarctic Icefish, the creature that had to give up its blood to stay alive. This isn't some minor mutation, it's a radical redesign of life. Hemoglobin is the biological workhorse that powers nearly all complex life on Earth. It's the red pigment in your blood, the reason your veins look blue and your cuts bleed crimson. But it's more than just color. Hemoglobin is the molecular truck that carries oxygen from your lungs or gills to every cell in your body. Without it, most organisms would suffocate in seconds. So how is the Antarctic Icefish doing any of this without it? Think of your bloodstream like a city. Oxygen is the food delivery system, and hemoglobin is the fleet of trucks delivering meals to every building. Now remove the trucks and try feeding the entire city with nothing but foot couriers. That's the icefish's biology. No trucks, no hemoglobin. And yet, the deliveries are still being made. Under a microscope, their blood looks alien. No red cells, no dense networks, just plasma, clear, watery, and nearly empty. This is the only vertebrate we know that has completely abandoned hemoglobin. Most animals can't afford that luxury because oxygen doesn't dissolve well in blood plasma. It's like trying to deliver air through a bottle of water. And here's the kicker. Scientists aren't even fully sure how they survive. There are theories, but the fact that this fish is alive, thriving, and has turned off one of the most essential proteins in evolutionary history, it's not just rare, it's nearly impossible. Imagine looking at an X-ray of an ice fish and seeing right through its head. That's how transparent parts of its body are. It doesn't just lack blood, it lacks biological modesty. It's like evolution pressed delete on half its bloodstream and said, let's see what happens. Let's look at where this ghost fish actually lives, the Southern Ocean. This isn't just cold water. It's water so brutal, it by rights should be solid. Antarctic seas can drop to -2 degrees Celsius and stay liquid only because of their salt defying the very physics of freezing. And that changes everything, because when blood loaded with hemoglobin hits these temperatures, it stops flowing, it turns sluggish, thick, like motor oil left out in a blizzard. Red blood becomes a death sentence. The very molecule that keeps you alive becomes the thing that kills you. In this deep freeze, hemoglobin shifts from a biological necessity into a lethal sludge. It clogs, it stalls, it risks crystallizing inside the smallest capillaries. For almost any other fish, that's a cardiac arrest waiting to happen. But for the icefish, this extreme environment offered an evolutionary bypass. It simply abandoned hemoglobin. It didn't need it. Cold water is naturally hypersaturated with dissolved oxygen, far more than warm water could ever hold. The ocean itself became the life support system. So the icefish cut out the middleman. No hemoglobin, no red cells, no risk of sludge. Just clear water, pure oxygen, and an open circulatory highway. In a wasteland where any other heart would seize or suffocate, the icefish found a way to drift through the impossible. So, how does a vertebrate survive with ghost blood? It doesn't just survive. It operates on a total circulatory redesign. The icefish didn't just delete hemoglobin, it supercharged everything else to compensate. Let's start with the engine, the heart. In a standard fish, the heart is compact, efficient, moving dense, oxygen-heavy blood. In these sub-zero depths, that strategy is a dead end. So evolution built a monster. The icefish heart is massive, 5 times the size you'd expect for a fish this small. And it doesn't just pulse, it hammers. It's a high-volume pump, forcing massive amounts of fluid through the body every second. And because that blood is clear and cell-free, it's thin, it's light. Think of it as switching a machine from heavy grease to high-performance hydraulic fluid. This allows the ice fish to survive on nothing but the oxygen dissolved directly in its plasma. The cold water provides just enough fuel to keep the lights on, barely. But this fix is a double-edged sword. The ice fish is now a prisoner of the freeze. It's locked into a niche so extreme that almost nothing else can touch it, but it's a one-way ticket. There is no plan B, no fallback. If the ocean warms or the oxygen drops, the entire system collapses. And yet, it works beautifully. The ice fish cruises with a liquid in its veins that feels more like industrial coolant than anything living. It's fast, it's thin, and it's just enough to fuel those ghost white muscles. This isn't just a minor tweak to the blueprint, it's biology rewritten. The ice fish didn't just bend the rules of life, it burned the rulebook and built a new one from the ashes. And it all starts with water in its veins. Just when you think the ice fish couldn't get any stranger, it doubles down. Because surviving sub-zero water isn't just about a hard upgrade. It requires molecular armor. The ice fish synthesizes something almost alien to the vertebrate world, antifreeze glycoproteins. These are specialized molecules patrolling the bloodstream, designed to stop deadly ice crystals from anchoring. In these temperatures, even a single microscopic shard of ice is a jagged razor. If it grows, it will rip cells apart from the inside out. It's a slow-motion explosion within the veins. But these proteins are the ultimate chemical bouncers. They latch onto forming ice seeds and freeze their growth in its tracks. They aren't just enduring the cold, they are chemically neutralizing it. This biotech is so efficient that the fish's internal fluids remain liquid even when the surrounding ocean is technically a deep freeze. It's a biochemical superpower so precise that scientists are now looking to harvest these proteins for medicine and cryopreservation, hoping to learn how to pause life without destroying it. Combined with that massive heart and its clear, oxygen-rich plasma, the ice fish does more than just survive the Antarctic. It thrives there, a cold-blooded masterpiece engineered for the 0 point. This isn't just life in the cold, it's life because of the cold. For all its incredible adaptations, the ice fish pays a price, and it's a steep one. This isn't some evolutionary upgrade that made it better in every way. It's a high-risk trade-off, one that locks the ice fish into a razor-thin margin of survival. Without hemoglobin, the ice fish has almost no room for error. It relies entirely on cold, oxygen-rich waters. If the temperature rises just a few degrees, or if oxygen levels drop slightly, its entire biology could collapse. This is a creature built for one environment and one only. Its large heart uses far more energy than a normal fish's, and pumping massive volumes of blood constantly is exhausting. It can't power bursts of speed like predators. It can't tolerate warmer seas. And it can't migrate to safer waters. It's trapped in the cold. This fragile balance makes the ice fish one of the most specialized and most vulnerable vertebrates alive today. Evolution gave it a system that works brilliantly in one place, and nowhere else. And as the oceans warm and oxygen levels fall, we might be watching the beginning of the end for this living anomaly. Because when you rewrite the rules of biology, the fine print always comes with a cost. The Antarctic icefish is one of the strangest creatures ever discovered, not because of what it has, but because of what it's missing. No red blood, no hemoglobin, no safety net. And yet, it lives. It swims beneath Antarctic ice with vodka clear blood, a heart like a hydraulic engine, and proteins that cheat death at the molecular level. It is a vertebrate that completely abandoned one of biology's most fundamental traits and survived anyway. But it's more than just an oddity. The icefish is a lesson, a reminder that life doesn't always follow the rules. That evolution isn't a straight line, it's a gamble, a series of impossible bets made over millions of years. And sometimes, the weirdest answer is the one that works. In a world where most fish would freeze solid or suffocate, the icefish thrives. It's not a monster, it's not a mutant, it's a marvel. A ghost swimming through the cold, surviving on a biological loophole. And if evolution could create this, imagine what else is hiding beneath the ice. If you enjoyed this story, hit that like button, subscribe, and check out our deep dive into polar gigantism. Because the cold doesn't just change biology, it rewrites it.